In the last video, we talked about how knotweed arrived in some of the countries that it currently impacts. We also learned that it has some negative effects on the ecosystems that it occupies, such as loss of biodiversity, soil erosion, riverbank destruction, and increased sediment loading in streams. But how does an invasive species damage an ecosystem? To visualize this, we need to talk about a concept called succession. In ecology, succession is the observed change in the types of species in a particular ecosystem over time. There are two types of succession that are important in this video. Primary succession occurs when an area that has never been previously occupied begins to be colonized by plants. Examples of this include quarries, volcanic hillsides, and beaches. Take beaches, for example, where the ocean often acts as a disturbing force. Initially, primary colonizers may move in that are adapted to the high salinity and other harsh conditions. These plants help stabilize the soil and make it suitable for secondary colonizers, such as grasses, to move in, which may further increase organic matter, nutrients, and soil stability. This may be followed up by bushes and then again by large trees later on, which establishes a climax community which may make itself suitable for animals to come into the area. Secondary succession occurs when a previously established climax community is disturbed or wiped out by a disastrous event. Examples of this would include clear-cutting in managed forests, such as softwoods in Nova Scotia, forest fires, or flooding in riparian ecosystems that wind up moving a lot of plants around. In this case, steps are often skipped, so you may not need primary colonizers initially, as the soil has already been stabilized enough for other plants to immediately become established. With that said, we need to talk about riparian zones. Riparian zones are areas where rivers or streams interface with land. These areas are very prone to flooding, which is a serious disturbance. It often disrupts well-established species such as trees and embedded herbaceous perennials like goldenrods and grasses, which have relatively fibrous root systems that stabilize soil and prevent erosion. These floods are also very good at distributing plant propagules such as rhizomes and nodular stems, both of which knotweed can use to establish itself. So you might be wondering how exactly knotweed leads to soil erosion. In the previous video, we discussed that knotweed has a 300 plus centimeter tall canopy, as well as rhizomes that can reach up to 2 meters deep underground. Due to the presence of a dominant seasonal canopy from the knotweed, native plants that would have provided a good fibrous root system for retaining soil are often outcompeted and removed from the area, leaving the soil easily eroded by flood actions. If we look at a bird's eye view of an example riparian area, you can see how knotweed might start to take over. If you have two isolated knotweed stands, say in the middle of this example zone, the shading from that knotweed allows it to spread out from where it's already established. However, when flooding comes along, it may break off chunks of that rhizome, and along with that soil being tilled up by that flooding action, knotweed rhizomes may have a chance to become established and dominate another part of the riparian zone. And year after year, this can become something of an issue, as the knotweed will almost always win out in a growing competition. Thanks for watching this video. I hope that it's helped you understand why knotweed is such a problematic plant in riparian zones. In the next video, we'll be discussing herbicides, one of the tools that we have available to help manage Japanese knotweed.